Hello everyone, welcome to Alfonso Academy. I'm Sir Peter Alfonso and this is the sixth part of the chapter periodic classification of elements. So in this part we are going to discuss about the second periodic trend observed in the modern periodic table, which is in the atomic size. The size of an atom of any element is indicated by its radius. Atomic radius is the distance between the center of the nucleus to the outermost shell, and the atomic radius is given by the unit picometer, which is smaller than the unit nanometer. So 1 picometer is equal to 10 raised to negative 12 meter. Now when we talk about atomic radius, it is of several types like metallic radius, ionic radius, covalent radius, van der Waals radius. But as far as your syllabus is concerned, we are talking about the radius of an atom, which is the distance from the center of the nucleus to the outermost shell. So let's consider period 2 of the modern periodic table, which has the elements like lithium, beryllium, boron, carbon, nitrogen, oxygen, and we are considering their radius, the atomic radius, which is in the unit picometer. So lithium has radius of 152 picometer, beryllium has 111, boron has 88 picometer, carbon 77 picometer, nitrogen with 74 picometer, and oxygen with 66 picometer. Now if you see, I have arranged these elements like in the sequence in the second period of the modern periodic table. So lithium is with atomic number 3, then 4, 5, 6, 7, and oxygen has atomic number 8. So if you observe the atomic radius, the radius goes on decreasing. So as you move across the period from left to right, the radius, the atomic radius goes on decreasing. As the atomic radius decreases, size of the atom also decreases. So as you are moving in a period from left to right across the period, the atomic size decreases. Now why does it happen? Why the atomic size decreases as you are moving across the period from left to right? Why does it decrease? We must not forget, as we are moving across the period from left to right, atomic number increases. That means number of protons increase. Now protons are in the nucleus, they are positively charged. So nucleus also have positive charge. So the positive charge on the nucleus increases as we move across the period from left to right. The positive charge on the nucleus increases. Because of this increased nuclear charge, positive charge on the nucleus, the electrons are pulled towards the nucleus, which are negatively charged. They are pulled towards the nucleus, and that is why the atomic size goes on decreasing. So the positive charge on the atom on the nucleus goes on increasing by 1 unit as you move from across the period from left to right. Because of this, the electrons are pulled towards the nucleus step by step because of the increased nuclear charge, and that is why the atomic size decreases. Now you might have a question in your mind. Number of protons are increasing as you are going from left to right within a period. So number of electrons are also increasing. They have negative charge. So that means the positive charges and negative charges are equal but opposite. And the forces they experience, the protons and the electrons, will be also equal and opposite in direction. But why only there is an effect on the electrons? They are pulled towards the nucleus. What is the reason? The reason is very simple. I had explained you in a chapter gravitation about Earth and the apple. Apple accelerates towards the Earth. The forces are equal and opposite, but Earth do not accelerate towards the apple. The same thing happens over here. Electron is 1800 times lighter than the proton. So the mass of the proton is 1800 times more than the mass of the electron, and that is the reason the electron accelerates towards the proton and proton do not accelerate towards the electron. So protons are in the nucleus and the electrons accelerate towards the proton. So we say that the nuclear charge is pulling the electrons towards itself, and this is the reason why the atomic size decreases across the period as we go from left to right. So as we go across the period from left to right, the nuclear charge increases and the outermost electrons are pulled towards the nucleus. So the atomic radius decreases, decreasing the atomic size. This is what you have to remember. It's very important. Now let's talk about the atomic size of the elements in a group. Let's consider group 1 elements, which has the elements like lithium, sodium, potassium, rubidium, cesium. So I have written their atomic radii in the next column. So lithium atom has the radius of 152 picometer, sodium has atomic radius of 186 picometer, potassium atom has radius of 231 picometer, rubidium atom has the radius of 244 picometer, and cesium has atomic radius of 262 picometer. Now if you observe these numbers, the numbers are increasing. As you are going down, the numbers are increasing. That means the atomic radius goes on increasing as you go from top to down in a periodic table, in a group. So atomic radius increases as you go from top to down within a group in a periodic table, and then because atomic radius is rising, definitely atomic size also increases. So the atomic size increases as you are going from top to bottom in a group in the periodic table. Now there is a reason for this. On every stage, as you go from top to bottom in a group in the periodic table, at every stage a electronic shell is added on. Of course, the number of protons are rising. That means the nuclear charge, the positive charge on the nucleus is also rising. But because an extra shell, extra electronic shell is added on every stage, the distance of the outermost electron or the outermost shell from the nucleus rises, increases by a greater extent. So this is the exact reason why the atomic size increases as we move from top to bottom in a group. So as we move from top to bottom within a group, an electronic shell gets added, because of which the atomic radius increases, increasing the atomic size. So within a group, as we move from top to bottom, the atomic size increases, and as we move from across the period from left to right, the atomic size decreases. So this is the second periodic trend observed in the modern periodic table, which is in the atomic size. So that's it in this part. Next part will be coming with metallic and non-metallic character, which is the third periodic trend observed in the modern periodic table. So hope you have understood whatever I have taught you. Please like this video. Thank you very much for watching.